We are going to discuss sine law, which in a lot of places is often called the law of sines, which I think sounds super fancy. Okay, either way, sine law is basically one big ratio. And the beauty of sine law is that it is used when we don't have a right triangle. So now let me throw some triangle up here. I don't even know where the shapes are. Hello, shapes. No shapes. Oh, here's a nope. Okay. All right, here's a shape. Triangle. So this triangle is not right. Okay? So it's not a right triangle, which leads us to use sine law if we have a pair. All right, so the key to this is to have a pair. And when I say a pair, here's what I mean. If you know one angle, let's say that this is 55, and you know the opposite length, so let's say this is 10. This is a pair. We've got a side and an angle that are opposite each other. That's a pair. If we are looking for this over here, let's say we're looking for this length, and we have this, and this is, let's say, 70. This is half a pair, right? Like we're dealing with it, but we only know information about half of it. But we have to have a full pair in order to use sine law. So the next thing we're going to do is we're going to go ahead and label this. So this is, we'll call this A, angle B, and angle C. And then we always label the lowercase on the opposite side. So if this is angle A, then this is side A, like little a. And if this is C, if this is angle C, then across or opposite from it is going to be lowercase c. And then B is there, but since it's not really, there's no information with B, we're just going to kind of ignore B for right now because we don't need it. But if we were going to, this would be side B. Okay, so sine law looks like this. It's A equals the sine of A equals B over the sine of B equals C over the sine of C. And there's three ratios here, 1, 2, 3. And you're going to need information about at least two of them in order to make sine law work. So in this case, we've got C and we've got A. So we don't know anything about B, and that's just fine. We're going to ignore that. So I'm just going to remove it. So what I'm left with is A over sine A equals C over sine C. So I'm going to plug in everything I know. So my little a is x. I'm looking for information. Then I've got that over the sine of angle A. Well, angle A is 70. So I'm going to take the sine of 70 equals the length of C, which is 10, over the sine of angle C, which is 55. So now I've just got myself a little algebra problem here. So I'm trying to solve for x as per usual. And to do that, I need to start by finding the sine of angle of 70 and of 55. So the sine of 70 is 9.09 or 0.94. So I've got x over 0.94. And that equals 10 divided by the sine of 55. So I'm going to be really smart about this, and when I put this in my calculator, I'm going to hit 10 divided by sine 55. I'm going to do that all as one big step in my calculator. So I'm going to say 10 divided by sine of 55, and you should get 12.2. Now play with your calculator and make sure you're getting 12.2. You might have to put this in a different order. So figure out how your calculator reads that. But you should get that. So now we're just trying to find x. So that means we need to move this 0.94, and we're going to move it with multiplication because it's dividing. So then I'm going to say x equals 12.2 times 0.94, and I get 11.47. And there is my answer. So I know that this side, is 11.47. Okay, so you can do that. That's how you solve for a missing side on any of these triangles. And again, it doesn't matter if this is d over sine d equals g over sine g. All that matters is that you have a full pair and then a half a pair. So let's look at what happens if we're missing an angle. Let's draw another triangle here. Let's say, here's my triangle, and if I'm missing this side, but I know that this is 12, and I know that this is 62, and this is 18. Let's see what we've got now. Okay, do we have a pair? The question is, do we have a pair? And we do have a pair. I have a pair right here. I have this 18 and 62. That's a pair. And then I've got a half a pair right here. I've got information about half of that pair. So sine law says sine A, sorry, it says, that's not what sine law says. Sine law, what we just said, was A over sine A equals B over sine B. Now, here's the beauty of sine law. It can turn upside down. So what I mean by that is the reason it can turn upside down is this because, let's talk about this. If we have 1/2, isn't 1/2 the same as 4/8? It is, right? Like if I was going to divide those, I would get 0.5 on the same. But what if I turn that whole thing upside down? What if I had 2 over 1 equals 8 over 4? Well, this time I would get 2 equals 2. But either way, the relationship between 1 and 2 is the same as the relationship between 4 and 8. What doesn't work on this is if you go like 1, 2 over 8 over 4. See, that doesn't work. But as long as you've got the bigger numbers on the top and the smaller numbers on the bottom, it's fine. It's just the smaller have to be together and the bigger have to be together. So because of that, we can flip sine law upside down. So I can turn sine law over and say the sine of A over the sine of little a equals the sine of B over the sine of little b. So you can flip it upside down. The reason I'm going to flip it upside down is because I'm looking for an angle, which I should have written as a capital for you here and made your life easier. The reason I'm going to flip this upside down is because I'm looking for an angle, and it's easier to find things in the denominator than it is in the numerator, or in the numerator than the denominator. Ooh, I'm a mess. Okay, so I'm going to turn this upside down, which is allowed as long as the signs are either both on top or both in the bottom. It doesn't matter. All right, so we're going to say that the sine of A, I'm going to plug in everything I know, over 12 equals the sine of B, which is 62, over 18. So sine 12, and that's an x, right? Over sine of x over 12. And then here, same deal. I'm going to put in one big thing in my calculator, sine 62 divided by 18, and that should give you 0.04. If you are not getting 0.049, then you are hitting the buttons in the wrong order, and we need to work out how to do that. Okay, we're trying to get x alone, so that means we're going to multiply this 12 to get it out of the bottom. So we're going to have sine of x equals 0.049 times 12, which is 0.58. Now, like in SOHCAHTOA, when we're looking for a missing angle, we need to unsign the x, which means we're going to use our second function button. So we're going to say x equals the second function of sine of 0.58, and you crank that into your calculator, and you should get x equals 35.4, and we're using degrees. Okay, that's all there is to it. So as a quick recap, when you're doing sine law, what that means is that you have to have 2 of the 3 ratios. So you need to have sine A over A, sine B over B, or sine C over C. You must have a full pair and then another half a pair. It doesn't matter, but either way you need to be working with 2 ratios. It doesn't matter if the whole thing's written upside down or right side up, as long as wherever the signs are the same in both ratios. Whenever you're looking for an angle, you always have to use the second function button, and you always need to label it with a little circle to mean degrees. Okay, that's sine law. I hope you got it. Okay, good luck.